Hello, Mr. Allman here, and this is your Allman Cast on planning and investigation. In this video, I want to show you how to use this planning guide to be able to detail all the different aspects of the investigation that you need to consider before you actually start data collection. Now, I'm going to begin actually not at the top, but down in the middle section of the front, which is the dependent variable. I'm going to start here because very often for investigations in a DP class, the dependent variable is already determined for you, because the dependent variable is the actual topic of that investigation. To use an example from the beginning of the year, we can look at the rate of respiration. And in class, you remember that we did that using pill bugs. In this first box, I simply put the topic. I don't write the details about how it's going to be measured, but rather just the biological principle that's going to be tested. Then I can move over to the middle box and actually detail how it is that I'm going to measure respiration in this particular lab. As you can see, I'm going to measure that using a vernier oxygen sensor. So I've included both a method as well as a unit, which I'm going to use to be able to measure this. In addition to quantitative measurements, which would include the actual numeric data, it's also important that I pay attention to any potential qualitative measures, things that I can use my senses like sight, touch, taste, and smell in order to be able to recognize a difference in the thing that I'm measuring over the course of the experiment. Now, one of the things that I can look for in this particular experiment is any change that I can see in the behavior of the pill bugs, because their movement is significant to the amount of energy that they're actually consuming, and the energy that they're consuming, of course, is generated through cell respiration. Once I've determined the dependent variable, I can now move up and select my independent variable. This is the part of the experiment that I have the most choice over, because this is the condition that I'm going to change. Now I need to think about my knowledge of respiration and apply that knowledge to choose an appropriate independent variable, because the variable that I select here needs to actually be something that is theoretically or biologically connected in some way to respiration. So because I learned in class that temperature is an important factor that impacts the rate of respiration, I'm going to choose that as my independent variable. So I need to identify the variable, which is the temperature of the surrounding environment, and I need to include how it's going to be measured. So in this case, I will measure that with a temperature probe. So now I know what it is that I'm measuring and how it is that I'm measuring it. In this right part, I need to actually list the settings of my independent variable. The settings are going to be the specific variations of my independent variable that I want to actually test. So in this case, the number of different temperatures that I'm going to select. I should have 5 or more because that's the amount that's necessary in order to be able to get a sufficient range of data and thus make a conclusion about the effect of temperature on respiration. For this particular experiment, it's important that I don't go too high or too low in temperature because I'm dealing with a living organism. Likewise, for any experiment that you do, you need to think what is an appropriate range of independent variable settings, because that range might be determined by safety considerations, practical concerns regarding the equipment that you might have access to, and the difficulty of being able to actually set it up. Now, once I've determined the independent and dependent variables, I can move up to the research question. And that research question is going to simply start as the relationship between that independent and dependent variable. So something like, what is the effect of temperature on the rate of respiration in pill bugs? That's a good starting point, but this is not yet a specific and fully focused research question. The reason why it's not yet fully focused is because the specific temperatures that I'm choosing to test are not yet listed, and the means in which the rate of respiration is being measured is not yet specified, and I've included a common name for my organism as opposed to the scientific name, which would be more appropriate. So in order to improve this, I want to first look at temperature and add in the specific range. So I can include in parentheses the range of degrees Celsius that I'm actually specifically testing in this lab. In order to include more specifically how I'm measuring the rate of respiration, I'm going to add a clause measured by the decrease in percent oxygen concentration. And I'm going to eliminate pill bugs and instead include the scientific name, which is Armadillidium vulgare. So now with those additions, I've now created a fully focused research question. I can move down now to control group. So a control group is going to be used as a basis of comparison, one in which I've removed the effect of the independent variable, isolating out a separate condition to which I can compare my experimental group to. So as is the case in many experiments, I cannot have a control group, and so in this case I will have only experimental groups, and I'll be comparing the relative temperatures towards each other as opposed to comparing them to a control group. For my controlled variables, these controlled variables are going to be the conditions that would impact the results of the experiment. And so because they are significant to the rate of respiration, I want to be sure that those conditions are maintained. So I'm going to start with the number of pill bugs. The number of pill bugs will obviously impact the rate of respiration because if there are more pill bugs, then there's going to be a greater amount of respiration occurring. I'm going to include time because time, if I allow more time, then more oxygen will be consumed. I'm going to include total mass of the pill bugs because the size of the pill bugs is also significant to how it is that how much energy they're going to be consuming. A bigger pill bug will go through more respiration than a smaller pill bug will. And then finally, the volume of the container, because a larger container will contain more oxygen, and therefore I'm going to be recording a different percent decrease than if I had chosen a smaller container. So by keeping that volume consistent, that will ensure that any percent decrease that I record is going to be due to the actual respiration in those bugs. For each of these, I should include a brief description of how they will be controlled. The number of pill bugs I'm going to select is 10 per trial. The amount of time that I'm going to use is going to be 3 minutes. The total mass of the pill bugs. Now, it will be hard for me to determine this precisely, so therefore I'm going to designate a range. Most likely I would actually select some average size pill bugs, find the mass of them, and so I might find that it's going to be somewhere in a range between a total of 40 to 45 grams. So then, as long as it's within that range, then I'm going to assume that the effective mass is not going to be significant on my results. Sometimes it's not possible to get a controlled variable 100% perfectly controlled, but the fact that I'm paying attention to the mass of the pill bugs shows that I'm really thinking clearly and carefully about the setup of my experiment. And the volume of my container, the container is going to be a 250 milliliter plastic container. Okay, from this point, I have determined most of the significant portions of my investigation. And really at this point, I'm ready to go in terms of beginning to gather materials and to start work. These sections on the back, you should certainly begin to write down some ideas before you actually start your investigation, but definitely you may add to it over time, because once you actually begin work, you may find that there are more materials, you may find new ideas for things to research, add those on so that you can remember to include them in your lab report. Now I've included here just a few starter ideas that I would come up with just off the top of my head relating to this investigation. I would want to know some general information like, what is cell respiration? What is that process? How would I outline that? What are the inputs and outputs of that process? but I also want to include specific information that is relevant to my specific context. So what is the nature of pill bug metabolism? What do they eat? How do they process energy? How is that unique in this particular organism? And of course, since I'm selecting a range of temperatures, before I begin, I want to research and make sure that I've chosen temperatures that are safe for the pill bugs so that I'm not getting them too cold or too warm to the point where they might actually be caused harm. And the resources, the actual specific resources, again, this is something that you'll add to over time, but a starting point is always going to be your textbook. But the best scores and the best research papers, the best investigations are going to include information not only from the general generic biology resources, but you're going to be looking at scientific papers that will get more specifically give me work from other scientists on similar topics. And that is going to show a student who is really going above and beyond in the area of research, trying to gain knowledge that's going to help them in the design and interpretation of their report. Under considerations, I want to think first about safety. So in this case, since I'm dealing with a living organism, so I would be concerned with potential pathogens from the pill bugs. Otherwise, in terms of safety concerns, there's nothing pertaining to my safety that is really necessarily relevant. I want to think, secondly, about ethical concerns. In this case, because I'm working with a living organism, I want to ensure that I'm doing no harm to that organism. So an ethical concern is not harming the pill bugs themselves. So safety as it relates to me, and then safety as it relates to the pill bugs. And then finally, in terms of environmental considerations, if I'm taking pill bugs that are present within the classroom in an enclosed space, I'm not sure whether or not those are local pill bugs or pill bugs that came from somewhere else in the world. And so I don't want to be responsible for releasing pill bugs into the environment. So I'm not going to take them outside and let them go. I want to keep them within the school and not potentially contribute to the spread of an invasive species. So I've thought about safety, ethical, and environmental considerations. Now for each of these, I can say how is it that I'm going to mitigate or overcome those potential problems. In terms of pathogens, I'm going to ensure that at the end of the experiment that I wash my hands with soap for my own safety. I'm going to maintain a safe temperature range for the pill bugs because it's important for me to ensure that they're not getting too warm. And then finally, I'm going to return the pill bugs to their enclosure as opposed to releasing them outside or throwing them away to ensure that they're not getting out into the environment where they might cause harm. Okay, in these sections, I'm going to list relevant materials, so particularly materials that are important for me to be able to set up my investigation. The most important thing in this is not necessarily what is written on this page, but that you have really very carefully thought through the investigation from beginning to end. That you know conceptually through your research what it is that you know the science behind what you're doing, that you have considered any potential ethical, safety, or environmental issues, and you are actively working to not let those be a factor in your experimentation, and that you've thought through precisely how you're going to carry out the investigation, what those steps are, and materials that you're going to use for it. If you've thought through all of those things very carefully, then you're probably going to have a much more successful investigation, and you're going to be done much more quickly because you'll already have planned out exactly how it's going to work. So that is the investigation planning guide, which you can use to help design an investigation for any experiment that you do in DP science. Thank you.